Hello, this is Pre-Calc Lesson 92, probability of either or either, and permutations and combinations. So, mutually exclusive events are events that cannot occur at the same time, such as for a coin, a head and a tail. Okay, those cannot occur at the same time. It's one then the other. So the probability of having either event, this is the sum of individual events, right? So if we had the probability of heads or tails, it would be probability of heads plus the probability of tails. Okay, now we have two different ways we write these. So intersections are for both and probabilities. So if we have the probability of both A and B, this is the probability of A intersect B, which we write as this, kind of like this bridge of both. Okay, that is the and. Now the union is for or, so the probability of A or B is the probability of A union B, which we write as P of A U B. Okay? So in union, we have a special case if the events are not mutually exclusive. Right? This is for if they're mutually exclusive, we add them. Okay? If they are not mutually exclusive, what can happen is this double counting happens, meaning you count a certain situation twice. So we use this formula, A union B is the probability of A plus the probability of B minus the probability of A intersect B, A and B. Okay? The reason we do this is to avoid counting the same probability twice. Okay? And I'll show you examples of this. So, example 1, a card is drawn from a full deck. What is the probability that the card is an ace or a black card? Now, we first ask ourselves, are these events mutually exclusive? And no, they are not mutually exclusive. Okay, because you can have a black ace. So what that means is we don't want to, if we draw an ace and it's black, we don't want to count that twice. Okay, so this is when we do the probability of A union B is the probability of A plus the probability of B minus the probability of A and B. So what does that mean like with words? It's the probability of ace or black, and it's the probability of an ace plus the probability of a black minus the probability of an ace and black. Okay, so the probability of getting an ace, there are 4 aces out of the 52 cards, plus the probability of getting a black is half of the 52 cards, so 26 over 52, minus 2 of the aces are black, so 2 out of 52. And this gives us 7 out of 13 as our final answer. Okay, let's do another example. A field contains 4 white unicorns and 3 black unicorns. 2 of the white unicorns are magic, and 1 of the black unicorns is magic. What is the probability of choosing a unicorn that is either magic or white? Okay, so we first ask ourselves, are these events mutually exclusive? No. If we choose, I guess, a white unicorn, it can be magic. Same if we choose a black unicorn, it also can be magic. So neither of these are mutually exclusive. So we have the probability of magic or white is the probability of magic plus the probability of white minus the probability of magic and white. Okay, so in our field, we have 4 unicorns. We have 7 unicorns, right? 4 white and 3 black. So my base for all of these is 7. Okay, now the probability of choosing a magic unicorn, there's 2 white unicorns that are magic and 1 black unicorn that is magic, so the probability is 3 out of 7. Choosing white, I have 4 white unicorns out of the 7, and magic and white, I have 2 of them. I add these together and this gives me 5 out of 7. Okay? So, different probabilities. Let's talk about permutations and combinations. Okay? So, permutations, we have NPR. The formula is n factorial over n minus r factorial. Combination, we have NCR, which is n factorial over r factorial times n minus r factorial. Okay? I want to show you just how we can prove this is true, right? If we wanted to take the permutations of 7 things chosen 3 at a time, right, then normally we do 7 factorial over 7 minus 3, right, 4 factorial, which ends up being the same as 7 factorial over 7 minus 3 factorial, right? This is how we were doing it before when we were choosing, but it doesn't matter if you choose or if you do the formula, right? This is how we first learned it, but now you can just plug it into your formula. Much, much easier, okay? This is just a quick little reminder so that you're able to do permutations and combinations much, much faster. All right, that is all for today. 2 short videos in a row. You are welcome.